Hi all of you, welcome to another lecture of antenna and wave propagation. I am Maria Joseph, Assistant Professor of Ma Basilis Christian College of Engineering and Technology, Pyramid, leading this session. Before starting this session, I would like to thank the author of the book from which I have taken the pages from 620 to 623 for the explanation. The book is Antenna and Wave Propagation by K.D. Prasad, and it is published by Satyaprakashan Publications, New Delhi. My dear students, in this class, I am going to take another type of array and it is called the ENDFIRE array. Last day we saw how to make a broadside or how we design an broadside array. In this lecture, we are going to see another type of array which is called the ENDFIRE array. An ENDFIRE array is actually a number of identical antennas spaced equally along a line, and individual elements are fed with a current of equal amplitude but opposite phase. That is the difference between a ENDFIRE array and a broadside array. Okay, and I think you remember what was the maximum radiation direction of a broadside array. It was 90 degree and 270 degree. But in the case of ENDFIRE array, actually the maximum radiation is in the direction of 0 degree and 180 degree. Let us see. Okay, what is an ENDFIRE array? For an antenna array to be ENDFIRE, we need that the theta should be either 0 or 180, which was 90 and 270 in the case of a broadside array. Thus, for the array to be ENDFIRE, we have psi is equal to 0 and theta is equal to 0 or 180 degree. When psi is 0, how can we write? Psi എന്ന് പറഞ്ഞാൽ എന്താ? ബീറ്റ ഡി കോസ് തീറ്റ പ്ലസ് ആൽഫ. പക്ഷേ നമുക്കറിയാം psi എന്ന് പറയുന്നത് 0 ആയിരിക്കും ENDFIREന്റെ കേസിൽ. അങ്ങനെയാണെങ്കിൽ 0 is equal to beta d cos 0 plus alpha, and you get alpha is equal to minus beta d. What is the value of beta? 2 pi by lambda. So we have 2 pi by lambda into d. Now, as usual, we have to find out the direction of maximum pattern maxima. How can we find? Last class we have seen E is equal to maximum. E is equal to E0 sin n psi by 2 divided by sin psi by 2. Same way. അങ്ങനെയാണെങ്കിൽ numerator should be maximum. That is sin n psi by 2 is equal to 1, and you solve it. N sin by 2 is equal to plus or minus 2n plus 1 into pi by 2. Psi is equal to plus or minus 2n plus 1 into pi divided by n. For ENDFIRE case, we saw alpha is equal to minus beta d and psi is equal to 0. So, psi is equal to beta d cos theta minimum plus the value of alpha. What is it? Plus or minus 2n plus 1 into pi divided by n. So we have beta d cos theta maximum minus beta d is equal to plus or minus 2n plus 1 into pi divided by n. Okay. So we saw it. So taking beta d out, we have cos theta max minus 1 is equal to plus or minus 2n plus 1 into pi divided by n. Solving it, beta d താഴോട്ട് കൊണ്ടുപോയി cos theta max is equal to plus or minus 2n plus 1 into pi divided by beta nd plus 1. So theta max of minor is cos inverse of this whole value. Now, like we did in the last class, theta 1 ഉം theta max 1 ഉം theta max 2 ഉം നമ്മൾ കണ്ടുപിടിക്കുന്നു. For an example, n is equal to 4, d is equal to lambda by 2 and alpha is equal to minus pi. We find two values and please note that we get only 75.5 degree and yes, we get only that value because 7 by 4 cos inverse of 7 by 4 is invalid. It doesn't exist. Please note all those kind of things from the video and you will understand it. Next, the directions of pattern minimum. That is same way like in the last class we did the same thing. It is obtained by putting alpha is equal to minus beta d. Beta d cos theta minimum plus alpha is equal to plus or minus 2n pi divided by n. Now beta d cos theta, we take beta d out and we do cos theta minus 1 is equal to plus or minus 2n pi divided by beta nd, and on this substituting the value of beta, that is 2 pi by lambda into nd, you get this value. Understood? Now how are we solving this? Cos theta minus 1. You can write it as 2 sine square theta minimum by 2. Why? Since cos theta is equal to 1 minus 2 sine square theta by 2. That is minus 2 sine square theta by 2 is equal to plus or minus n lambda by n d, because you have this both one cut off, and sine square theta minimum by 2 is plus or minus n lambda divided by 2 nd. Sine theta minimum by 2 is equal to plus or minus root of n lambda by 2 nd. Now on solving you get theta minimum is equal to finally on solving you get theta minimum is equal to 2 sine inverse of plus or minus root of n lambda divided by 2 nd. Now the pattern minimum can be obtained by putting n is equal to 1, 2, 3 etc. And in the example you have n is equal to 4, d is equal to lambda by 2 and nd is equal to 1. ഇപ്പം നമ്മൾ ആദ്യം ചെയ്യുന്നതിനകത്ത് n 1 കൊടുത്തു, ഒരെണ്ണത്തിനകത്ത് n 2 കൊടുത്തു, ഒരെണ്ണത്തിനകത്ത് n 3 കൊടുത്തു, ഒരെണ്ണത്തിനകത്ത് n 4 കൊടുത്തു. ഇങ്ങനെ 4 നമ്മൾ ഡിഫറെൻറ്റ് ആംഗിൾസ് കണ്ടുപിടിക്കുകയാണ് എന്തിനാണ് പടം വരയ്ക്കാൻ വേണ്ടി. Thus the minima are situated at 60, 90, 120, 180. Minus 60, minus 90, minus 120 and minus 180, and you get the figure in the maximum കിട്ടുന്നത് ഏതായിരിക്കണം? In 0 and 180 you will get it. It is quite easy. I just said it fast only because believing that you know all this kind of things, because already I have explained this in the broadside array. Now beam width of major lobes. Okay, for that I will show you how we are finding it in this case. Look at this figure. Just look at this figure. That is, how do you find the beam width of a major lobe in the other one? In the case of broadside, it was between this and this, right? Between both this. But here the first null is here, and same way like the other one you are finding here also. So we have to find the beam width. How are we finding the beam width? Just put the same equation as the above. Okay, that is, here you have the beam width of major lobes. Beam width is equal to 2 into theta 1. Theta minimum is 2 sine inverse of plus or minus root of n lambda divided by 2 nd. We got it from the earlier equation. Sine theta minimum is equal to theta minimum. Why? Because if the angle of theta is very small, sine theta is almost equal to theta minimum. All these things we have said last day. Now, so we have theta minimum is equal to 2 into plus or minus root of n lambda divided by 2 nd. That is, we are taking this 2 inside, that is root of 4 n lambda divided by 2 nd. Theta minimum is equal to plus or minus root of 2 n lambda by n d. Fine. Now if the array is of length L, then L is equal to n minus 1 into d. L is equal to nd. Theta minimum is given plus or minus root of 2 n lambda divided by nd. That is equal to plus or minus, because L is almost equal to nd, and you place that L here. Beamwidth between the first two nulls is 2 into theta minimum. That is what you understand from that figure. I showed you the figure earlier, and we have BWFN is equal to 2 into this value, that is plus or minus 2 into root of 2n lambda divided by nd, and if n is equal to 1, and finally you get the BWFN is plus or minus 114.6 into root of 2 divided by L by lambda. Just compare the design or the patterns in the broadside array and learn this also in the very same way. Once again, I remind you about studying the broadside array and the ENDFIRE array together. Both these notes are available in the textbook of K.D. Prasad. Once again, thanking the K.D. Prasad for this valuable information in this book. Thank you so much.